Chapter 5, Section 6 is entitled Slope and Rates of Change. The objective here is to determine the slope of a line and recognize constant and variable rates of change. Now, the reason we're going to start talking about slope here, not only because it's about a line, and I've told you that that's where we're already heading here, is really time I've spent on talking about lines, is because slope, once we understand slope, we can write out specific types of equations that involve slope that don't require us to do nearly the amount of calculation we have to do to graph really what will have to be a line, because that's what slope is all about. But if we need understanding of slope before I can say, here's this form called slope-intercept, or here's this form called point slope. Once I show you that form, you'll just be able to graph it by looking at it. You won't have to do those calculations. If you don't know what slope is, you can't do it. So what is slope? Slope is a measure of the steepness of a line on a graph, the ratio of the rise to the run. When we look at the graph, we're going to say, how much does that graph change on the y-axis, the one that goes up down? That's what we call rise. And then we say, how much does it change on the x-axis, left to right? That's what's called the run, right? And that's what us finding slope is. It's the ratio of the rise to the run. How much it changes up, down versus how much it changes right, left. They give definition here, rate of change, because slope is a rate of change. Again, it's how much it changes up, down versus how much it changes right, left. So that's why they're defining that idea of rate of change here. It's the ratio of two quantities that change. All right, so let's look at this first question. We're supposed to tell whether the slope is positive or negative and then find the slope. You can have 4 different types of slope, just in general. Not talking about the numbers, just types. You can have positive, negative, 0, or undefined. Anytime the line tips up from left to right, whether it's not very steep at all or really, really steep, that's a positive slope. That also means when we compute the actual numeric value of the slope, that's actually going to have a positive answer. Whenever the line falls from left to right, again, whether it's really steep or not really steep at all, that's going to be a negative slope. And again, that also means that when I compute the numeric value of that line, the actual slope of the value of that line, that's also going to be a negative value. A line that is horizontal has a slope of 0. And a line that goes up, down, a vertical line, has a slope that's undefined. Now we can get really technical here, but usually what I tell people to think of here is, think of me walking across the floor. Walking across the floor is 0 challenge. Whereas if I get on like an inclined treadmill, I'm going to be huffing and puffing. All right? Walking across the floor is 0 challenge. And that helps me remember that because the floor is a horizontal surface and a horizontal line is obviously horizontal. So if you can associate the idea of horizontal and 0 together, you'll be in a good place. Then try and picture me walking up the wall. I can't walk up the wall. Nobody can walk up a wall. Right? It's impossible. Just like finding the slope of any vertical line. You can't find it. It doesn't exist. And we'll talk more about that in just a second here once we see how to compute slope, the actual real reason that those two are what they are. So, since this line in example 1 points up from left to right, that means it's got a positive slope. All right, now let's talk about finding the slope here. Now I know mine looks a little bit different than what's on your note guide because I've repasted the drawing so I don't have to toggle back and forth, but rest assured that's the exact same drawing you saw at the beginning of example 1 here. Slope is the rise compared to the run as we defined it a minute ago. So we're going to look at this line and talk about how much it moves up and then how much it moves to the right. In this question I'm saying up because we already said it's got a positive slope. It goes up from left to right. I could say down if it's got a negative slope if it tips down from left to right. So how do you find slope? What you want to identify are 2 points that go through grid markers. When I say go through grid markers, you want points that go through on the different perpendicular lines formed by the coordinate grid. You can do ones that go through the middle of a grid box like a point like this, but unless you're absolutely sure what that point is, you're going to have problems. So you don't really want to pick those. You want to pick points that go through grid markers. As you can see, this point goes through a grid marker, and this point goes through a grid marker, which is why they picked those two. Could I pick something else along the way? Absolutely. It doesn't matter what you pick as long as it's 2 points set on the line. No matter where you end up computing this from, the end result is the same. So what we want to do is calculate first how much, we're going to always do this from left to right, just like we read. All right? From left to right, how much I first have to do to go up or down to get from point to point. Now in this case, I'm going up, as I said a minute ago. So to go from this point to this point, I have to go 1, 2, 3 jumps up. So my rise here is going to equal 3. And then I'm going to look at my run. My run is how much I have to move to the right now to get over to this point in the end. Well, I've already made these 3 jumps up, so I'm here. Now I'm going to figure out how many I'm going to go to the right. And that's also 3 jumps to the right. So my run is equal to 3. So the slope of my line here that's being shown is 3 over 3. We can reduce that fraction to 1 over 1, and that's going to be the same as my slope. So my rise and my run here is 1 to 1. All right, now let's backtrack for a minute and talk about horizontal and vertical line now, because this is the real reason that those are what they are. If we talk about horizontal line, a line that goes left to right, horizontal line will never rise. Let's just say I go from here to here. I don't care what those numbers are, it doesn't really matter. A horizontal line will never have rise. So the top number in my slope fraction is going to be 0. My bottom number, my run though, to go from here to here, again we're always going to go from left to right just like we read a paper or a book, right? That's going to be some number, any number, 1, 2, 3, 4, 5, 6, 7, whatever. It's a number. Well, anytime I take 0 and divide it by a number, we know the result is always going to be 0. It doesn't matter if that bottom number is 1 or 2 or 3 or 5 or 10 or 208. All right? 0 divided by any number is going to spit out a 0 other than 0 itself. But when I have a vertical line, a line that goes up and down, right, this line here has rise. Let's say I'm going from here to here. All right? Again, I don't care what the number is. It's not really all that relevant. The problem is that this line never has any run. We never go to the right to get to another point. The bottom number here is 0. Well, as you know, we're not allowed to divide by 0. Think about it in terms of the fraction example we always use here. If I give you the fraction 0 over 2, that means I had 2 pieces of pie, but I didn't eat any of them. Or in Mr. Smith's case, maybe he ate both of them and didn't leave any behind. Anyway, 0 out of 2. 2 pieces of pie, none eaten. But if I flip it around, 2 over 0 means I didn't have any pieces of pie, but I ate 2 of them. You can't do that. That doesn't make any sense. All right, so in that particular instance, you can never have 0 in the denominator. And that's exactly what happens with a vertical line. That's why the vertical line has a slope that's impossible to find or undefined. All right, because it just simply doesn't exist. One thing to note here, in truth, in reality, all right, you don't always have to go from left to right. You can go from right to left. The problem is that's going to present an enormous amount of options here and more things we have to remember. And of course, we don't want more formulas and rules we have to remember. We want less. So we always go from left to right, which is always going to cause our run number, the bottom number in the fraction, to be positive. The rise, yes, we could end up going down to get over to this other point, and that one could be negative. But the way we do these questions, going from left to right all the time, that run number is always going to be positive. All right, let's go ahead and take a look at the next one here. Use the slope -2 over 1 and the point 1, -1 to graph the line. That's all we need. That's all I need to graph a line, because they're giving me a point, and then from that point, I'm going to extrapolate the slope to give me another point, and once I've taken and carried that out, I've got 2 points. It only takes 2 points to graph a line. So let's see what we're going to do here. You're actually going to start with the second piece of information they gave you here, which is 1 over 1 comma -1. So you're going to graph the point 1 comma -1, just like we learned in Chapter 5, Section 1. So 1, -1, remember that means I go to 1 on the x-axis and -1 on the y-axis, pull my fingers together, and that's this point you see here in green. There's 1, -1. Then what you're going to do after you plot that point is you're going to plot the slope. Now the slope here is 2, -1. That means I'm going to have a rise of -2 and a run of 1, and I'm going to plot my other point. Now the mistake people make here is when they want to plot the slope, they start back here at the origin sometimes. You're actually going to start at the point you've already made, the point that I've shaded here in green. A rise of -2 means I'm going to go down 2 units. Rise is always up or down. Positives are up, negatives are down. So I'm going to go down 2 units. And then my run here is 1. That means I'm going to go to the right 1 unit. Remember, we're always going to go to the right the way we solve our questions here. So I'm going to go to the right 1 unit and put my next point. That takes care of my slope. Now I have 2 points. I connect my points, and there's the graph of the line. Again, slope is only applicable when we're talking about lines. So if I'm talking about slope, it has to be the graph of a line. So if you graph this and you get something that's not a line, you did something wrong. All right, now this one is talking about whether the graph shows a constant or variable rate of change. What you have to know is, when we were talking about slope and lines just a second ago, no matter where I calculate the slope of a line at, which 2 points I pick that happen to be on that line, the slope is always the same. That's kind of what the word constant means. Constant means it's not changing, okay? Always the same. So anytime you have a line, all right, the rate of change, because remember slope is the rate of change as we talked about in the definitions, the rate of change is going to be constant. When you have anything else, something else, whatever, all right, that's going to indicate a variable rate of change. Let's talk about this example you see on the screen right here, this kind of stretched out W looking shape. Let's just talk about this in pieces in terms of slope. It doesn't really have a slope because it's a line, but if I look at it in pieces, I can kind of talk about it that way. All right, if I start with the left side, over here, all right, again, I'm just going to treat it like I've only got this little piece here. All right, that little piece points down from left to right. So if I said find the slope, you're going to figure out the numbers, no problem. But you're going to say it's a negative because it points down from left to right. Then when we get to here, all right, if I was just looking at that piece right there, that piece here has positive slope. Again, you can figure out the numbers. It can be whatever. The answer is going to be positive. Well, that right there alone indicates that we have a variable rate of change. Because in order to have a constant rate of change, the slope, if this had a slope, but the slope would have to be the same all the way through. Here it's negative, here it's positive, and I haven't even gotten to the rest of the graph. Right? Well, if one's negative and one's positive, the number isn't the same all the time. That's exactly what variable means, is that the numbers are going to be all over the place.